Alright guys, let's open up to page 46. So yesterday we started our kind of graphical analysis section, and we were taking a look at particular points on a graph. Whether we want to plug in an x value, we can figure out where the y value is, or vice versa. If we plug in a y value, we can figure out where the x value is. I think yesterday went kind of very smoothly for us. Would you agree? If we can remember from yesterday? Okay. Today we're going to continue looking at some graphs, but instead of looking at particular points like we did yesterday, we're going to analyze intervals. And we're going to look at specific characteristics. For instance, if you take a look real quickly on page 46, where is that graph decreasing? Where is that graph increasing? Where is that graph constant? Okay, and we're going to continue to look at some other characteristics like where is this graph positive? Where is this graph negative? Okay, we can analyze graphical representations not only in terms of points, but intervals as well, and that's what we're going to focus on today. But the big thing is when you're ever going to analyze a graph, you know how you read a book from left to right? You read a graph the same way. So whenever you're analyzing a graph, kind of like how we were dragging our pencil, remember yesterday we always start on the left and then go to the right? We're going to continue that process. Okay, so you always read a graph from left to right just like you read a book. So I don't know if you have a marker or highlighter or colored pencil, or maybe you just want to draw in kind of dark using your pencil. Let's go ahead and identify on these three graphs where we are decreasing, where we are increasing, and where we are constant. Can you actually physically draw on those graphs those sections? Okay, you want to go ahead and think about it. If you were to trace this graph from left to right, I want you to think about where is your pencil or pen or marker going down. Okay, that would be for decreasing. Where is your pen or pencil going up? Okay, that would signify a portion where you're increasing. And when on this graph is your pen or pencil flat? Meaning you're constant. You're not going up, but you're not going down either. Bless you. Bless you. Gonna go for 3? No. I just gotta tell you guys, I have never in my life sneezed more than twice in a row. So I'm absolutely fascinated by people who can do 3 or more. So if someone does that in here, you're gonna see me get super excited. Okay? I've never been able to do it. I don't know why, but yeah.
Every time after my dad finishes eating, I don't know why, but it happens without him. I don't know, he just goes in this sneezing fit. He sneezes 10 times.
After eating?
Yeah, every single time, without fail.
See, sometimes, when I'm inside and it's really sunny outside, you know that feeling when you squish your face together? I really think I'll sneeze 3 times when that happens, because I'll go 1 and then I'll go 2, but I never go 3. Yeah.
I don't think I've ever sneezed just 1 or 2 times. I always sneeze that.
So you always do more?
Yeah.
Oh, man. I could never do it. Bless you, bless you, bless you, bless you. Wow. Yeah, I've never been able to do it. I'm still waiting for my day. All right, can we identify those sections, those chunks? Okay, yeah. Oh, okay, so we're already starting on the next ones. Okay, so now that we can physically draw them in, no, that's okay. Okay, Marie's getting ahead of us, that's okay. Now that we physically drew them in, we're going to go ahead and identify those intervals, meaning beginning point, ending point, stuff like that. Now, before we get there, okay, so Marie told us the first interval was -5 to -3, right? Taking a look at that x-axis, we begin at -5 and it ends at -3. Okay, now if we're going to use an interval, we have to make sure that we use the correct notation. We need to figure out, should we have parentheses or should we have bars? Or brackets, sorry. Parentheses or brackets. Any thoughts? Yeah.
Brackets.
Why brackets?
Because the dots are like
Okay. So when we did domain and range, okay, if you could physically touch that point, we used a bracket. Are we answering a domain question in this case? Aren't we answering where we're decreasing? Right? It's not asking about domain, it's asking about where you are decreasing. So I want you to think about this. So I understand why you say bracket, okay, because we do physically have points there. But if you could imagine, okay, put yourself on this first point right there, could you tell me for sure if you are going down? If you're just standing there, are you moving down? Are you decreasing? No. Okay, so even though we physically have a point there, we would use a bracket for domain because that point exists. But in terms of answering the question, are you decreasing, we would say no, because technically you're not even moving yet, right? So in this case, we would need a parenthesis. It's all about what the question's asking you. It would be a bracket for domain because the point exists. But are you actually decreasing? No. So we would use a parenthesis. Okay? So again, we're going to start here. Imagine walking this path. So all these points in here, you're walking down, right? And then you get to this point right here. Can you say for certain that you're decreasing right there? If you're standing right at that point, are you traveling up? Are you traveling down? Isn't that kind of where you change, right? So if you change direction, you can't really say for certain if you're traveling down or up because you're making that change. So we're going to need another parenthesis there. If it was a domain question, that would be a bracket because the point actually is there. But this is a decreasing question. Are you actually decreasing? Okay, we're going to get used to the difference. We have another interval, right? So we have to take that one into account as well. If you have another interval, do we remember that little symbol we need? Yeah. It's a U for union, okay? So our next interval looks like we go from 4 to 6. If you were to physically stand at that point of 4, can you say for certain if you're increasing or decreasing? No, so that would be a parenthesis. And then if you were physically standing at that point of 6, could you say for certain you're decreasing? Nope, so another parenthesis. All right, let's go ahead and try the next one, increasing. So we identified -3 to 0, and that's the only one. Are you actually increasing at -3? If you were to stand right there, are you traveling up for sure? No, because you're changing direction, right? So parenthesis. What about at 0? If you were to stand there, are you traveling up? Isn't that another change in direction? You go from up to flat, okay? So you're not strictly increasing there either. So that means our last interval for the flat piece, we would have from 0 to 4. And those would also be parentheses because we have some changes in direction at those endpoints. Okay? So if it's asking about domain and the point exists, you definitely use brackets. But increasing and decreasing, not necessarily. Okay? It's all about if you are actually increasing or actually decreasing at those points. Can we understand or see the difference? Okay, it's all about what the question's asking. So, just to reiterate this, should your intervals identified above as closed intervals, did we identify them as closed intervals using brackets or open intervals using parentheses? Give a reason for your choice. What did you notice about all of these? Yeah. They're using parentheses. We have open intervals. Okay, we're not including any of those endpoints. So we'll say the intervals should be open because What do you want to use as your reason? Okay, give a reason for your choice. Good, Marie? The direction, what? Sorry, I can't hear you. The direction is unknown at those points. Okay, so open intervals because the direction is unknown. Maybe we'll say slash changing, okay, at the x values, or at the x value endpoints. Okay, so you can't say for certain if you're going up or going down, you need a parenthesis. Or you can think about it, if your direction is changing, you need a parenthesis. Okay, this is only for increasing, decreasing, and constant. If it was domain, it'd be something different. We're doing okay? All right, so speaking of domain and range, let's go ahead and check out the bottom two questions. Identify the domain of the graphed function. Okay, so yesterday when we did our, not yesterday, I think it was 2 days ago, when we did our free response, remember we dragged our pencil, okay, trying to figure out where we started, where we ended? We're going to do the same thing here. Okay, so put your pencil on the left-hand side of the graph, and as you drag it across left to right, where's the first x value that your graph begins? Can we identify it? Yeah. -5. Do you physically have a point at -5? Yes, it's closed, right? So there we need a bracket. As you keep dragging your pencil across your graph, when do you stop touching a portion of it? Yeah, 6. Do you physically touch 6? Yes, there's a closed circle there. Okay, so that would be a bracket. All right, so we're going to do the same thing for the range. This time we're going to start low and then drag our pencil up. So start below the graph. As you drag your pencil up, notice how it starts at -3. We have a closed circle there, so that would be a bracket. And as we continue to drag, we are always touching a portion, it looks like until we get to 5. So that would be a bracket as well. Okay, so domain and range, okay, brackets may be necessary, but for increasing, decreasing, and constant, they should be open because we have those changes in direction. Okay? All right, so graphical characteristics, we can analyze where we're going up, where we're going down, where we're flat. Maybe we'll take a look at where our graph is positive, where our graph is negative. Okay, all these different characteristics or properties. Okay, so take a look at these questions. Which variable, x or y, does the notation f of x represent? F of x is the same thing as y. Good. Okay, so we're only looking at the y value. So if I told you or gave you the notation f of x equals 0, this is basically asking you when is the y value 0, right? Because f of x and y are the same thing. Okay, so if I told you f of x equals 0, where would you be located on a graph? Can you describe, perhaps, where the y value is 0? Yeah. On the y-axis? That would be an x value of 0. Right there. Because here's an x value of 1, here's an x value of -1. So x value of 0 would be the y-axis. We want a y value of 0, though. Here's a y value of 1. Here's a y value of -1, which means y value of 0 is the x-axis. Okay, so if you know the y variable is 0, your graph is located on the x-axis. What's another word for x-intercept? A synonym? 0. Okay, so if your y value is 0, okay, it's called a 0, then you are on the x-axis. You have an x-intercept. Okay, what about the second notation? What if your y value is greater than 0. Okay, if you think about some numbers greater than 0, like 1, 5, 10, aren't all those numbers positive? Okay, so where would you be graphically if all of your y values are positive? Yeah. The upper part, you'd be above the x-axis, right? If you look at all these y values of 1, 3, 5, those are all positive. Those are all above the x-axis. What if I told you your y values were less than 0? You're probably thinking we'd be below the x-axis, right? Okay, so getting used to notation, okay, mathematical representations here. Remember, f of x is the same thing as y, and we are comparing to see if y is equal to 0, or y is greater than 0, meaning positive, or less than 0, meaning negative.
Hello? Show my phone. You may see me in the office real quick.
Alright, so now that we know what this notation means, let's go ahead and, very similar to the increasing, decreasing, and constant, let's go ahead and sketch or label on these graphs where those characteristics occur. So for this first one, we want a y value that's exactly 0. That means our graph is exactly on the x-axis. So we can identify those locations of our graph. Now the next graph is asking us where are the y values bigger than 0, meaning positive. So that would be where the graph is above the x-axis. We can go ahead and label all those points. We might have to be a little bit more specific on this one, okay? Do you see how the way I drew it right now, I kind of start at that -3? Are we above the x-axis at that -3 value? Didn't we say we're on it exactly over here? Okay, so notice how there's no bar underneath that inequality, right? We want to strictly be above the x-axis. So in my head, or maybe you want to be specific and write this on your paper, we need to realize that this is an open circle location. You are not including that point because that point is specifically on the x-axis, and we only want points that are above the x-axis. So very similar reason, this location should also be open, and so should that one, right? Okay, let's go ahead and try the next one. Where are we only below the y-axis? We can locate those locations, and we need to be careful because, again, technically this spot should be open, and so should that one. Okay, so now that we identified these sections, let's go ahead and label them in terms of mathematical notation, what these regions represent, either exact points or intervals. So go ahead and identify the x values for the highlighted portion of the graph. So in the first one, we are only talking about these 3 points. Notice how it's not an interval, right? There's no beginning value, ending value. If you're only talking about specific points, those are specific x values, like x equals something. We don't need to worry about brackets or parentheses, at least in this case. So the x values look like -3, 0, and 6. When you look at the next graph, though, we are going to need some intervals because we have all of these points that are going on that are above the x-axis. Okay, so we kind of have to use that either bracket or parenthesis depending on the case. So if you take a look at your interval here, again, maybe you want to drag it from left to right. As you start to drag, isn't the first point you encounter that -3 location, right? But we said we cannot include that point because that point is technically on the x-axis and we only want points above the x-axis. So what kind of grouping symbol do we need on that -3? Yeah, we need a parenthesis. As you continue to drag your pencil, notice how we have another issue happening at 0, right? We are not touching the graph there, at least in terms of being above the x-axis. So our first interval would be from -3 to 0. We have another interval, right? We have more graph to include. So let's go ahead and throw in that u. And notice how the second interval is going to begin at that 0 and looks like it ends at that 6. We cannot include either of those because they're technically on the x-axis and we only want to be above. Are we doing okay? All right, let's try the below portion. So as we start to drag our pencil, looks like the first point we identified was at -5. And as we continue to drag, the interval looks like it's going to end at -3. Let's see. Is the point at -5 below the x-axis like we want? Yes. So this one would be a bracket. Is the point at -3 below the x-axis like we want? Yeah. No. So it's going to be a parenthesis. We have another interval, right? Towards the right-hand side. So we need that u. And let's go ahead and fill in that interval. It looks like we go from 6 to 7. We said that 6 was not below the x-axis, so that would be a parenthesis. But notice how the point at 7 is below, so that would be a bracket. All right, so similar question to before. Should your intervals be identified as closed, meaning just brackets, or should they be identified as open, just parentheses? What do you think? Or is there another option that maybe we can discuss? Yeah. It could be both. Okay, notice how in this last piece, didn't we have a mixture of a closed point and an open point, right? Okay, so we'll say a mixture of both may be needed. Okay, not all the time, because if you take a look at the middle graph we did, weren't both of those open intervals? Okay. So a mixture might be needed because, what do you want to give as your reason? Why did we need brackets on the -5 and the 7, whereas compared to some of the other ones we just needed parentheses? Yeah. Okay, because some of the end points may, we could say, satisfy or answer, whatever wording you want to use. We'll say the question being asked. Okay, notice how -5 satisfied the notation of being underneath the x-axis, because that point right there was below. Same idea with 7. That point satisfied that question being asked. Okay, so you may need a mixture. So if you're just increasing, decreasing, and constant, we said they would always be open. Okay, but if you're analyzing where you're above or below or even on the x-axis, you may need that mixture. Okay, depends on the analysis that you're doing. Let's go ahead and try domain and range for this graph. Do you guys think you can give it a shot? Drag your pencils left to right, up to down. Try to identify the beginning and ending points. Any takers on domain? If you drag left to right, where do you begin and end? Yeah? 7 bracket. I like it. Did we get it? Okay. Drag a pencil left to right. Looks good. You can touch both endpoints. What about the range? Low to high this time? Yeah? 4 bracket. How do we do? Pretty good? Awesome. All right. So that's it for this section. Okay. We have quite a bit of time left. Hopefully yesterday you started some of these problems on 49. Okay. If you want to go ahead and try some of the ones on the back, you can. Okay. But before you do that, we're going to have a homework quiz.